This is the video for section 7.1. In chapter 7, we're going to go back to talking about triangles and how to solve triangles. For the most part, these will not be right triangles. When we talk about a triangle that's not a right triangle, the general name for that is an oblique triangle. If we're trying to solve an oblique triangle, when we talk about solving a triangle, that means to find the measures of all three sides and all three angles. We can do this with an oblique triangle if at least one side and any other two measures are known. We're going to talk about 4 different cases of this. We'll classify this as what information we already know. So the first case is called SAA, or side angle angle, or ASA, which means angle side angle. And the way these are written tells you where the side is and the two angles that we know. This one means that we know one side and two angles. The SAA, where we have side angle angle, if we have SAA, that means that we know one side. Let's say that we know side A, and then since it has the S and then the A and the A, that means the side that we know is not between the two angles, but we have the side and then two angles after that. We could either know side A and angles C and A, or we can know side A and angles B and A. And one thing to remember when we're doing all of these is that if you know 2 of the angles, you can always get the third using that rule that the 3 angles have to add up to 180 degrees. So this would be the SAA case. The angle side angle case that would be where we do know the side that's between two angles. So for instance here, if we know side A, to make it angle side angle, that means that we would know angles B and C. The next case is called side-side angle. This means that we know 2 sides and 1 angle. And this angle, because of the way this is written, it is not the angle that's between the 2 sides. And in this case, we might have more than one triangle. For instance, if we know angle A and sides A and B, this would be SSA, because we've got a side and then the angle, but the angle is not the one that's between the 2 sides. Here would be an example where we could have more than one triangle. If we knew this angle and we knew the length of this side over here and the length of this side, we could also have this triangle where this side swings over this direction. So this would be one triangle, this would be the second triangle. The third case is side angle side. This one we also know 2 sides and the angle between the 2 sides. For example here, if we knew angle C, this would mean that we know the 2 sides that are adjacent to C. So we would know sides A and sides B. Then the last case is SSS, which is side, side, side. That means we know all 3 sides. But we don't know any of the angles. The one case that isn't listed in here is AAA, which would be angle, 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 because that doesn't give us a unique triangle. If we know the 3 angles in the triangle, we could have an infinite number of triangles that would satisfy that. Now here's a formula that we're going to use to solve a lot of these triangles. This is called the law of sines. What this says is that the lengths of the sides in a triangle are proportional to the sines of the angles opposite the sides. If you want to put it in terms of a formula, if you have sides A, B, and C and angles A, B, and C, then we can write ratios that have the side and the sine of its corresponding angle. For example, A over sine of A equals B over sine of B. You can do this with any 2 of the sides and their corresponding angles. Let's look at an example of solving a triangle using the law of sines. In this problem we know 2 of the angles and we know 1 of the sides. For these problems, you always want to draw your triangle. So I'm going to try and draw this as accurately as I can with what I know, which is these two angles. So I'm trying to make this one about 32 degrees. And then I want to have an angle up here that's 81.8 degrees, so I'm going to make it so that it's just a little bit less than 90 degrees. This would be my angle A, this would be my angle B. That means my side A is across from angle A, so this is A over here. And you can see here I've got side, angle, angle. Well, what I want to use is the law of sines. When I'm using the law of sines, I always want to locate a side and the angle that corresponds to it where I know both of those two values. I have it here because I know side A and I know angle A. I want to set up my ratio then so that I have A over sine of A. Since I know angle B, I could solve for side B, so the other side of my proportion would be B over sine B. I'm just going to plug in the values that I have. The quantity I don't know here is the B. Now I'm going to take this equation and solve it for B. I can cross multiply. That would give me the 42.9 times the sine of 81.8 equals B times the sine of 32. The other way I could think about solving this is just multiplying both sides by the sine of 81.8. Those two cancel out on that side, and that will give me B. What I'm going to put in my calculator is 42.9 times the sine of 81.8 degrees divided by the sine of 32 degrees. Two important things with your calculator here. One is make sure your calculator is in degree mode. You might have it in radian mode from some of the previous units that we've done, but at least for this week you want to make sure it's in degree mode for all of these problems. The other thing with your calculator is when you're doing this with the sine of 81.8, make sure that you close your parentheses before you put in the division sign. If we work this out on the calculator, this turns out to be 80.1. So our side B is 80.1 centimeters. Now to solve the entire triangle, we still need to know angle C and side C over here. Now angle C we can get because we have the other two angles in the triangle. If we add these up and then subtract from 180, then we have 180 minus 113.8 degrees, which is 66.2 degrees. So that's our angle C. Now because we have that, we can use the law of sines again and find side C. I'm going to go back to A and sine of A since I had both of those given. That's 42.9 over sine of 32 degrees. And then I'm putting in C, and I know my angle C. So this is A over sine of A equals C over sine of C. And I'm going to solve this for C. Again, I can just multiply on both sides by the sine of 66.2. And then if I work this out on my calculator and round this to one decimal place, I get 74.1 centimeters. One thing you can do with these once you have the triangle solved is you can do a check for reasonableness comparing the lengths of your sides and the sizes of your angles. Remember that the largest angle is going to be opposite the longest side. In this one, B was our biggest angle at 81.8 degrees. That's opposite our longest side. The smallest angle should be opposite the shortest side. So we have 32 degrees here and 42.9 centimeters for A. And then the angle in the middle should be across from the side that has the length that's between the other two. Now let's look at an application example. In this one they already drew the picture for you. We've got angle C right here is 112.90 degrees. We have the measure for angle A, and we know the length of side B. And what we're trying to find is the distance A across the river. What we would want to do is set up our law of sines so that we had A over sine of A. Now the other side that we know is B, we need to know angle B to be able to set up the law of sines. We can get angle B just by adding up our other two angles and subtracting that from 180. If we add up our other two angles, that gives us 144 degrees. So if we subtract that from 180, we get 36 degrees for B. Now we can set up our law of sines. We would have A over the sine of A, which is 31.10 degrees. And then we're going to use B and angle B. B is 347.6 feet. And our angle B is 36 degrees. If we want to solve this for A, we're going to multiply both sides by the sine of 31.10 degrees. That answer, if we round it to one decimal place, is going to be 305.5 feet. That would be our distance A. On this one, we can check that this is a reasonable answer. Notice that angle A was a little bit smaller than angle B. That means that side A should be smaller than side B. And it did come out, this is 305.5, and B was a little bit longer at 347.6 degrees. Another formula that uses the sines of the angles is one to find the area of a triangle. And this works if you have two sides and the angle in between them. So if you have the SAS case. If you do, then the area for the triangle is 1/2 times the product of the two sides times the sine of the angle in between. Don't memorize the formulas so much as memorize the form. So this is 1/2, then you have the two sides, and then you have the sine of the angle. This angle is not the one that corresponds to either of the two sides. So you've got 1/2 the product of the lengths of the two sides, and then the sine of the angle that's included between those two sides. Let's look at an example for this one. We're trying to find the area of this triangle. What we have here is side C, and this would be side A, and we know the measure of angle B. So the area formula that we're going to use, we're going to have our sides A and C, so we'd have 1/2 times A times C, and then the sine of B. All we have to do now is plug in these numbers. I'm going to go ahead and put the units in here. This is 42.0 feet, and then the sine of 55 degrees 10 minutes. To get degrees in minutes on your calculator, you have to use that angle menu. If we work all this out, this is going to come out to be 586, and since we had feet times feet here, this ends up units being square feet or feet squared. Here's another one. What we need for this area formula is two sides and an angle. In this one right now we have two angles and one side. So we're going to have to find another side before we can go on and use our area formula. We've got side B, so we need to either find side A or side C. But to do that, we can use the law of sines. We know angle A and we know angle C. Since we know side B, we're going to have to know angle B to do the law of sines. For angle B, we're going to take these two angles and add them together. Again, you can do this with your calculator using that angle menu to get degrees in minutes. So if we take 24 degrees 40 minutes plus 52 degrees 40 minutes, that adds up to 77 degrees 20 minutes. Then we're going to subtract that from 180, which is going to give us 102 degrees 40 minutes, and that's our angle B. Now we can set up our law of sines. Let's say that we're trying to find side A. We have A over sine of A, which is 24 degrees 40 minutes, equals B over the sine of B. To solve this for A, we're going to multiply on both sides by the sine of 24 degrees 40 minutes. That's going to give us A equals 11.6775 centimeters. Now, I'm not rounding this very much because I'm actually going to use this value in the formula. Now we're trying to find the area of our triangle. Since the two sides that we have now are A and B, the formula that we're going to use is 1/2 AB sine C. So there we're just plugging it into the formula, and if we work this out we get 127.6 square centimeters.